Today we are doing very important question, Charpit method. This is very important question for competitive exam. So for solving this, first we write the auxiliary equation we need for solve this. Easily we can write dx by minus fp. Fp means del f upon del p. Okay. Then dy upon minus fq. You can see a pattern to remember this. Okay. dz upon minus p fp and qfq. Okay. And then here x, y, z, and now dp upon fx, now in denominator fx, and pfs fz, and dq upon fy plus qfz. Okay, you can remember this very easily. This is the auxiliary form of Charpit equation, and using these you have to solve. You need to find value of p and q, and then use this formula dz equal to p dx or q dy. Sometime you can find the value of p and q and then put the original given equation. Then also you can find the value of z. Now we see some question. You can see this is z equal to px plus qy plus p square plus q square. Okay, now we write it as this is function f x y z p and q. This will be z minus px minus qy minus p square minus q square. Okay, now first fp means del f upon del p. This will be with respect to p partially differentiated, it is minus x minus 2p. Okay, fq del f upon del q. Del f upon del q partially differentiated with respect to q, it will be minus y minus 2q. Okay, now fx will be del f upon del x. Del f upon del x will be here minus p. Now fy del f upon del y. Del f upon del y will be minus q, and now fz will be del f upon del z, and it is 1. Okay, you can see. And now write the auxiliary equation. What is the auxiliary equation? Dx upon minus fp dy upon minus fq dz upon minus pfp minus qfq. If you write 2 or 3 times this formula, you will definitely able to remember this. Okay, dp upon fx plus p fz and dq upon fy plus qfz. Okay, now put all these value here. Dx upon minus fp, it will be x plus 2 to p or q, 2p. Okay, similarly dy by minus fq is minus y minus 2q. This will be y plus 2q. dz upon minus pfp, fp is minus x minus 2p minus q, fq is minus y minus 2q. And dp by fx is, you can see, minus p plus p. fz is, fz you can see 1 into 1. And similarly dq by fy is minus q plus q fz, and fz is 1. You can see dx upon x plus 2p, dy upon y plus 2k, and dz upon minus p minus x minus 2p minus q minus y minus 2q, and dp by 0 and dq by 0. Now you can find out the value of p and q using these two. How can we can find out? We can write dp by 0 equal to these all are equal, so we put the equal to lambda, dp equal to 0, and now we need to find value of p. So integrating, then it will be p equal to c1. Okay, now similarly we can take dq equal to 0. Now dq equal to 0, and again integrating, it will be q equal to c2. Now put this value p of q in this equation. What is the equation? Original equation is z equal to px plus qy plus p square plus q square. Now z equal to c1x plus c2y plus c1 square plus c2 square. This is the original solution of required equation, where you know that c1 and c2 are the arbitrary constant. Okay, thank you very much. Now we will solve another question.